Hello guys, welcome back to another fun day of math notes. Right, today we're doing 2.6, which is all about rational functions and asymptotes. So 2.6 is the second half of the chapter 2 notes. And so we're kind of like not starting a new unit, but it's kind of we're splitting this unit in half, and this is the start of the second half of the unit. So we have three objectives today. The first one is we're going to look at how do I find the domain of rational functions. And we already know how to do that, so that should go pretty quick for us today. Then we're going to start looking at how do I find the horizontal and vertical asymptotes of a graph. And those are going to come into play pretty heavily for us here in this section and the next section. And then we're going to use rational functions to model and solve real life problems. So what we mean is write an equation, that's the model part, right? Write an equation and then solve the equation. So the first thing that we have to do is we have to talk about rational functions, right? What is a rational function? So a rational function is a quotient, which means it's division, but it's division of two polynomial functions. Meaning I have a polynomial on top and I have a polynomial on the bottom. And so when we're looking for the domain of this, it's the set of all real numbers except anything that makes the bottom 0. I know in a fraction, I am not allowed to have 0 in the bottom, right? So I can plug in any numbers I want except for numbers that would give me 0 in the denominator. So we're going to look at a couple quick examples, and I think we'll be good to go here, okay? So first one is find the domain of f of x equals 1 over x and discuss the behavior of f near any excluded x values. So the first thing I'm going to start with is the domain, right? What is the domain? Well, up above, what we just said is that it's the set of all real numbers, so x is in the set of all real numbers, except whatever value gives me 0 on the bottom. Well, in this case, the only value that I can plug in to get 0 on the bottom is 0. So there's my domain. So that's my excluded value. I'm not allowed to have 0. So I want to know what is happening at 0. Why am I not allowed to have 0? Right? And I'm going to draw a quick sketch of what this graph looks like. We know what this graph looks like. We know about all of our hyperbolas. That was really bad. Sorry, let's see if I can do better. My pin is already jumpy, you guys. Just starting the video. It's gonna be fun. Okay. Something like that, right? So we have to actually look at what's happening as x approaches 0. We're going to use some new notation here. As x approaches 0, but as x approaches 0 from what side, right? From this side, because it's in quadrant 1 here, but it's in quadrant 3 here. So what is it doing? And then we have this little plus sign, and that means from the right. So what is x, or what are my y values doing as my x gets closer and closer and closer to 0? So as my x values get closer and closer and closer to 0, my y values are increasing, increasing, increasing all the way to infinity. So as x approaches 0 from the right, f of x, or my y values, approaches infinity. Okay, right? So as I get closer to 0, I get infinitely close to 0, and this graph just keeps going up and up and up towards infinity. Okay, now let's look at the other side. As x approaches 0 from the left. So now I'm getting closer to 0, but I'm going this way, right? So as I get closer and closer and closer to 0, my graph continues to go down, 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 down. So my f of x, my y values, approach negative infinity. Just keep going down. And we can do this for other values as well. Like, for example, we can do, let's say also, like as x approaches infinity, let's just say, right? So as my x values go out, forever and ever and ever, my y values just get closer and closer and closer and closer and closer to 0, right? I never cross over. I have an asymptote here. So my f of x approaches 0, right? I have asymptotes. Maybe let's make a note of my asymptotes. So we have asymptotes at x equals 0, which is the y-axis, and y equals 0, which is the x-axis. Okay. And then I can also figure out what is x doing as it approaches negative infinity. Right? So now as my x values go out here and get negative, 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 my y values continuously get closer and closer and closer to 0 again, right? Because there's an asymptote there. It doesn't cross over 0. So again, f of x approaches, I almost wrote infinity. Sorry. There we go. 0. Right? So as my x values get smaller, 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 my y values get closer and closer to 0. So really what it comes down to is the domain are any values I'm not allowed to have in the bottom. So let's look at these 3 examples and see what we can come up with. The first thing that we have to know is that I should always factor first. I'm going to factor everything I can first. So in this case, because we remember how to factor, right? X squared minus 25 should be a quick factor. It's just x minus 5, x plus 5. And that is over x minus 5. Okay, so it wants me to find the domain. So in this case, my domain is x is in the set of all real numbers, but x cannot equal anything that makes the bottom 0. Well, the only value that would make the bottom 0 here is positive 5. Right? I'm not allowed to have 5. If I have 5, then the bottom 0, and it's no good. Then it says also find the zeros. Well, zeros are anything that makes the top 0. Okay, so my zeros, let's look. Here, if I plug in 5, I would get 0. But right here, it tells me I'm not allowed to plug in 5. So that, even though it would make the top 0, I can't have it because I'm not allowed to plug in 5. Okay, so that one's no good. This one, if I plug in negative 5, I would also get 0, and that's okay. I'm allowed to have negative 5, right? I just can't plug in positive 5. And that's it. So my domain is x is in the set of all real numbers as long as it's not 5. And then my zeros is negative 5. So this tells me that the graph crosses the x-axis at negative 5. Okay, for g, I'm going to do the same thing. Can't factor the top, but I can factor the bottom. So that's x minus 5, x plus 5. And let's look at my domain. So domain is x is in the set of all real numbers, and x cannot equal anything that makes the bottom 0, which in this case is 5, right? Positive 5, and also negative 5. I can't have either one of those two because that would make the bottom 0. And then my zeros is anything that makes the top 0 that I'm allowed to have. Well, the only thing that makes the top 0 is 0. So in this case, x is 0, and that tells me that this graph crosses the x-axis at 0. Okay, and then the last one, none of these are factorable, so I can't factor, so I'm just going to leave it. So my domain is x is in the set, right, of all real numbers. And then x cannot be anything that makes the bottom 0. So as I'm looking here, no matter what number I plug in, I'm going to get a positive number or 0, right? So there's no way that this bottom will ever be 0. So I actually don't have any exclusions here. My domain is all real numbers. I can plug in anything my little heart desires. Okay. The next thing to find is zeros. What value would give you 0 at the top? And in this problem, it would be -5. Excuse me. So this tells me that the graph crosses the x-axis at -5. Hopefully we feel good about this. It is a little bit of a review, but if you need help on this or this is not making sense, please make sure that you reach out so that we can get help and you don't get too far behind. We talked a little bit about arrow notation here. So there's just 4 possibilities, right? X can approach a number from the right. X can approach a number from the left. As x approaches infinity and as x approaches negative infinity. And this is used a lot in calculus for limits, which we're not going to talk about too much in this class. But for now, we're just going to go ahead and write it like what we did on example 1 up above, right? As x approaches infinity, f of x approaches 0. And so that just means, as x gets bigger and bigger and bigger, my y values get closer and closer and closer to 0. So what I want you guys to do is on this page, I want you to see if you can figure this out. Okay? See if you can figure out what x is as it approaches -2 from the left, or as it approaches -2 from the right, or as it approaches 4 from the left, or 4 from the right, or negative infinity, or infinity, okay? So I do want you to try it. It's better to try it and mess up than not try it at all. So give it a shot, and then when you're ready to go over it, just hit play. All right, so let's review these. Here it wants as x approaches -2 from the left. So here's -2, here's the asymptote. And as I get closer and closer, oops, my pen is nowhere near. As I get closer and closer and closer to -2, my graph is decreasing, 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 right? And it just continues to go down. So as I approach -2 from the left, my f of x approaches negative infinity. Okay. Now let's look, as I approach -2 from the right, right? My graph is increasing, 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 and it continues to go up. So as I approach -2 from the right, I'm going to positive infinity. Now it wants as I approach 4 from the left, right? And I know it's left because of the minus. So as I get closer and closer and closer and closer to 4, my graph continues to go down. So as I approach 4 from the left, I approach negative infinity. And as I approach 4 from the right, my graph is going up, 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 which would give me positive infinity. And then the last two is as x approaches negative infinity. So as my x's go out this way, I'm getting closer and closer and closer to 0 because there is a horizontal asymptote there. And as I approach infinity or positive infinity, right, my graph continues to get closer and closer and closer to 0 because there's a horizontal asymptote. Now, the question that comes up is, well, Ms. G, there's a horizontal asymptote, then how can this graph cross the x-axis, right? Because you can't cross over a horizontal asymptote. And the answer to that is when you are in between two vertical asymptotes, your horizontal asymptote is not valid in between two vertical asymptotes. So because I'm between two vertical asymptotes, I can actually cross over the x-axis. And that is something that we will get to later. So don't stress about that too much. So hopefully we're feeling good on our notation. It's really just making sure that we feel comfortable with this notation. Because because we're going to look at how do you find where is my vertical asymptote, where is my horizontal asymptote. Okay, so vertical asymptote obviously is vertical. And this is what I really want to make sure we are clear about. Okay, vertical asymptotes occur when something is a zero of the denominator, so of the bottom, but it's not a zero of the top. Okay, so if something is a zero of the bottom, but not of the top, it is a vertical asymptote. If something is a zero on both the top and the bottom, that's what we call a hole. And what happens there is I'm just going to draw a graph that like doesn't make sense, but just stick with me, okay? So let's say I have a hole somewhere, right? That just like means that the graph literally just jumps over and there's no value there. Okay, so the graph is no longer continuous. There's just no value at that point. So that's if you have something that's a zero of both the top and the bottom. So let's look at some examples of these and see if we can figure out where my vertical asymptotes are and if there's a hole. So again, first step, always factor everything that you can. Okay, so this is x plus 5, x minus 5 over x minus 5. Okay, so the zeros of the top are, you don't have to write this part, okay? So negative 5 and 5. The zeros of the bottom are 5. So in order to find my vertical asymptote, it has to be a zero of the bottom, but not of the top. So in this case, my zero on the bottom is 5, but since it's also at the top, I don't have a vertical asymptote. So in this case, there is no vertical asymptote at all. But what that does mean is that there is a hole. Oops, there's a hole, right? Because if something is a zero of both the top and the bottom, then it's a hole. And so in this case, the hole's at 5. And then to find the y value, like where else, like 5 what? 5, 1, 5, 2, 5, 3, right? Where's the hole? What you do is you cross off the things that created the hole. So I'm going to rewrite this just so that we can manipulate it a little bit better. Okay, so the x minus 5, that's where my hole is. So I'm going to ignore that. And then I have x plus 5 left over. So you write everything that's left over, whether it's on the top or the bottom. And then you just plug in your x value. So I get 10 because 5 plus 5 is 10. So the hole is located at 510. So that means that at 510, like right here, there's just a gap in the graph. Like the graph is doing something super awesome. That's not even what the graph would look like remotely, sorry. Right, the graph is doing something like this, and then, right, whatever. And there's just a gap right here at 510. Nothing. Okay. So let me get rid of all of this stuff. And let's look at another example. Okay. Here, again, I'm going to factor everything. So x on top over x plus 5, x minus 5. Okay, my vertical asymptotes are where the bottom is 0, but the top, or like, right, whatever zeros I have on the bottom that are also not on the top. So in this case, I have negative 5 is a 0. Is negative 5 a 0 at the top? No. So that tells me I have one vertical asymptote at x equals negative 5. at the vertical line, x equals negative 5. Here, positive 5 is a 0. Is that a 0 of the top? No. So I have another vertical asymptote at positive 5. Okay. And then does the graph have a hole? Well, again, do I have a 0 that's common on both the top and the bottom? Right? On the top, my 0 is 0, and then on the bottom, it's negative 5 and positive 5. So I don't have one in common on both the top or the bottom. So in this case, there's no hole. Okay, lastly, is this guy. Again, it's not factorable. So my vertical asymptotes occur when the bottom is 0. Well, the bottom here is never 0. So there's no vertical asymptotes. And if there's no vertical asymptotes, let's look at the top. The bottom is none, right? And the top is negative 5. And those definitely aren't common. So there's also no hole here. Okay, so that vertical asymptote occurs when the bottom is 0, but not the top. And then a hole occurs when both the top and the bottom share a 0. So hopefully we're going to get so much practice on this, but take a deep breath, right? Pause it if you need to, take a break, whatever you need, okay? We're going to move on to horizontal asymptotes. Okay, so horizontal asymptotes, right, are horizontal. And there's only 3 options. Okay, and it depends all on the exponents of the graph. Okay, so let's say that I have a graph like A, where A is any real number, okay? AX, the N over BX to the M. I'm just making stuff up, but let's just say that this is what we have, okay? If N is smaller than M, and we call it bottom heavy. So if the exponent on the bottom is bigger than the top, it's bottom heavy. And if it's bottom heavy, y equals 0 is the equation of the horizontal asymptote. It's right there on the x-axis. Okay? If these two are equal, then it's balanced. And what you do is you take A over B. And that's where your asymptote's located at, whatever that A over B. If this is 6 and this is 2, then your asymptote is located at y equals 3, right? Because 6 over 2 is 3. If N is bigger, we call it top heavy. Kind of makes sense, right? And there's none. There's no horizontal asymptote if a graph is top heavy. So again, let's look at these examples. Oh, that is not what I wanted to do. Sorry. There we go. So let's look at these 3 examples and see if we can figure out, does it have, let's show this, there we go. Is it balanced? Is it bottom heavy? Is it top heavy? What does all that mean? Okay, so in this case, the highest degree on the top is a 2, right? And then the highest degree on the bottom is a 2. So since they're both a 2, this is balanced. And since it's balanced, I take the coefficients in front of both of the x squareds, and that is the equation of my horizontal asymptote. So that graph has a horizontal asymptote at the line y equals 9/5. So 1.8, right? Wherever 1.8 is, that's where that line is. For G, the exponent on the top is a 1. The exponent on the bottom is a 2. So since the exponent on the bottom is bigger, this is bottom heavy. And since it's bottom heavy, the equation y equals 0 is the equation of the horizontal asymptote, right? So it's just right there on the x-axis. It hasn't moved up or down. And then the last one here is my top exponent is a 3. The degree of the top is the 3. The degree of the bottom is 2. So because the degree of the top is bigger, this is top heavy. And since it's top heavy, there is no horizontal asymptote. So it has nothing to do with the 9 and the 5, right? We're looking at the exponents, the degree of the polynomial to determine if those are top heavy, bottom heavy, or balanced. Okay. Let's try an example where we're doing multiple of these steps together. Okay. So example 2 says, find all horizontal and vertical asymptotes of the graph. So the first thing we want to do is factor anything that we can. In A, this is not factorable, so I'm just going to leave it. And that's okay. Okay, so let's look. My vertical asymptotes are anything that make the bottom 0. Well, since I have this x squared, right? X squared, the smallest number I can get out of x squared is 0. I'm never going to get a negative number out. And so the smallest number I can get out is 0, and 3 times 0 is 0. 0 plus 1 is 1. I'm never going to get 0 on the bottom. So because of that, there are no vertical asymptotes in this graph. Then we want to look at the horizontal asymptotes. And so I need to ask myself, is this equation top heavy, bottom heavy, or balanced? Again, the exponent of the top is 1. The exponent of the bottom is 2. So this is bottom heavy. And since it's bottom heavy, that means the equation y equals 0 is my horizontal asymptote. So this graph has a horizontal asymptote on the x-axis, and it has no vertical asymptotes. And that's all I know about it so far, and that's okay. We'll get there, right? Let's look at B. So for vertical asymptotes, step 1. I didn't even listen to my own advice, right? Factor everything. This bottom is a perfect square, so it factors to x plus 1, x minus 1. Okay, so here I have a 0 at negative 1. If I plug negative 1 into the top, do I get 0? No. So that tells me that I have a vertical asymptote at negative 1, right? Because it has to be a 0 of the bottom, but not of the top. Here I have a 0 at positive 1. If I plug in positive 1, I don't get 0. So I have another x-intercept. Another vertical asymptote at 1. Holy moly, I'm tired. Okay. And then the last thing we need to find is a horizontal asymptote. So for the horizontal, I'm going to look back at the original, right? I have x squared on top and x squared on the bottom. So this is balanced. And since it's balanced, I'm going to take the coefficients in front of the x squareds, which in this case is 2 over 1, which is just 2. So I have a horizontal asymptote at 2. So just to kind of show you what we're talking about here, and I'm going to guesstimate. Maybe I should actually draw it. Perfect. Okay, so I have a a horizontal asymptote at 2, and I have one vertical asymptote at negative 1, and one vertical asymptote at 1. And at this point, I don't know what else my graph looks like. I could find it. I could show you, because I do. I know, right? Right, the graph is doing something like this. And then this guy, because it's between vertical asymptotes, I can actually have it cross over that horizontal asymptote. So the graph ends up looking something like that, which again, we don't know how to do yet, but we will. So get ready. Right, we're gonna have so much fun. Okay, let's look at example 3. Example 3 says find all horizontal and vertical asymptotes in the holes, and then also find the zeros. So a lot going on here. First thing I always need to do, factor. If you don't know how to factor, you're going to be in big trouble on this section, okay? So x squared plus x minus 2 factors to x plus 2, x minus 1. And x squared minus x minus 6 factors to x minus 3, x plus 1, 2. Wow. Wow. That's a 2. Okay, so now I factored. So now I can find my vertical asymptotes, right? Positive 3 is a 0 on the bottom. Is it also a 0 on the top? No. So x equals 3 is a vertical asymptote. Negative 2 is a 0 on the bottom, but is that also a 0 on the top? Yes. So it's not a vertical asymptote. It's actually going to be a hole, but we'll do that in a second. Okay, my horizontal asymptote. Is this equation top heavy, bottom heavy, or balanced? So we look at our original equation. My highest degree here is a 2. My highest degree here is a 2. So it's balanced. Okay, if you need to make a note of that to yourself, please do. Balanced. So I'm going to take the numbers in front, which in this case is just 1 over 1, which is 1. So y equals 1 is my horizontal asymptote. Okay, now the hole, I have a negative 2, 0 on the bottom and a negative 2, 0 on the top. So my hole is at negative 2. And then let's make a little note of this. To find the y value of the hole, we're going to plug negative 2 into x minus 1 on top and x minus 3 on the bottom. Remember, I'm not plugging it into what created the hole. So these guys created the hole, so I'm not going to look at that then when I'm solving. So then I get negative 2 minus 1 over negative 2 minus 3. I get negative 3 over negative 5, which is just positive 3 over 5. So the hole is at negative 2, 3/5. And then the last thing is the zeros. Where does this graph cross the x-axis, right? And that is anything that's a 0 of the top, but not of the bottom. So the opposite, right? So here, the only thing I haven't used left is this x minus 1. So I have a 0 at x equals 1, or at 1, 0. This graph crosses the x-axis at 1, 0. So I actually know quite a bit about this graph now, right? I know, and you don't have, oh gosh, you don't have to sketch it, but just to show you kind of where we're going with this, okay? So here's the graph. It's beautiful. You did an awesome job. Oh, shoot. 34. Something like this. I just want to show you where are we going with this, right? So I have a vertical asymptote here at 3. I have a horizontal asymptote at 1. I know that at -2 3/5, so like here-ish, there's a hole. And then I know that it crosses the x-axis at 1, 0. So I can tell you that this graph is doing something. There you go. Like this. And we will get more precise with that, but just to show you where we're going with finding all of this information. Okay, let's go on to example 4. We're getting close. For the function f, find A, the domain. So part A wants us to find the domain. Part B wants us to find the vertical asymptote. And part C wants us to find the horizontal asymptote. And this looks like Des Moines. There's the A. All right. So I know that my domain is going to be x is in the set of all real numbers, right? But x cannot be whatever makes this bottom 0. I don't know what makes this bottom 0, so let's find out, right? I'm going to take my -4x cubed plus 5, and I'm going to set it to equal. Set it equal to 0, right? What value of x gives me 0? I don't know. Let's find out. Subtract 5, so I have -4x cubed equals -5. I'm going to divide by -4, so x cubed is equal to 5 over 4. And then let's take the cube root. Make sure you write the little 3, right? And I get x is equal to the cube root of 5 over 4. And I have no clue what that is. It's probably some nasty decimal, so we're just going to leave it, okay? So the cube root of 5 over 4. So x can be anything, any real number, no imaginary, but any real number that I want, as long as it's not the cube root of 5/4. Okay? Now, my vertical asymptote is anything that's a 0 of the bottom, but not of the top. Well, the only 0 of the bottom is this guy. And I'm going to go ahead and assume that that's not a 0 of the top, right? So x, there is a vertical asymptote at the cube root of 5/4. And that makes sense. Think about it. I'm not allowed to plug in a number at the cube root of 5/4, whatever that is, right? And the reason I'm not allowed to plug in a number there is because there's an asymptote. The graph never gets there. So that makes sense that it's not part of the domain because I'm not allowed to plug a number in for that value because there's a vertical asymptote there. And then my horizontal asymptote, my degree of the top is 3 and my degree of the bottom is 3, so it's balanced. Maybe I should write that. Balance. Since it's balanced, we're going to take the coefficients, right, which is 3 over -4. So the equation is -3 over 4. And I just moved the negative to the 3. But you can write it 3 over -4. Okay, so again, I found the domain, the vertical asymptote, the horizontal asymptote. It doesn't ask me for anything else, so I'm done. Let's look at one more example before we do our 2 word problems. And this one's kind of going the opposite way. So it tells me, write a function, rational function, with vertical asymptotes at -3 and 2, a horizontal asymptote at -5, and zeros at -4 and 6. So 1, I know it's going to be a fraction, so I'm just going to go ahead and draw my blank fraction. Okay, Vertical asymptotes are when there's zeros on the bottom, but not the top. So that tells me that x minus -3, right? So x plus 3 is a 0 on the bottom. And it tells me that x minus +2 is a 0 on the bottom. Because the only way that they can be vertical asymptotes is if there's zeros on the bottom only. Okay, the horizontal asymptote seems kind of tricky, so I'm going to hold off on that. And then zeros are when I have zeros on the top only. So now I know that I have x minus -4, so +4, and x minus +6. Okay, now remember that for horizontal asymptotes, my options are either y equals 0, right, none, or if it's balanced, I can have a over b. Well, in this case, it's not 0, so it's not that. It's definitely not none. So we're looking here. So my a is -5 and my b is 1, right? If I make it a fraction. So that tells me that this equation is balanced, which it is, right? I have a degree of 2 on top. This is a 1 and a 1. There's 2. And a degree of 2 on the bottom, 1, 1. So this is balanced. So that means that my coefficients for the front are -5 and 1. And that's what gives me the horizontal asymptote. And then the last thing is they actually want the function. So I'm going to multiply it out. I'm going to ignore this -5. I'm just going to leave it there for now. And I'm going to multiply. I get x squared minus 2x minus 24 over x squared plus x minus 6. And then the last thing, now I can multiply the -5 in. So I get -5x squared plus 10x plus 120 over x squared plus x minus 6. And that is my rational function that has vertical asymptotes at -3 and 2, horizontal asymptote at -5, and zeros at -4 and 6. Right? It's a lot. I get it. It's a lot. Don't worry, we'll get lots of practice, okay? 2 examples left, and we are done. You are going to want your graphing calculator for these. So if you need to pause and go get your graphing calculator, please do so. Okay, so example 6 says, a utility company burns coal to generate electricity. The cost in dollars, C, right, C is the cost, of removing P% of the smokestack pollutants is given by this equation, 80,000 P divided by 100 minus P, where P is between 0 and 100, which makes sense, right? You either remove 0% of the pollutants, or you can remove up to 100% of the pollutants. So, right, makes sense. Use a graphing calculator to graph this function. Okay, so let's start there. Let's use a graphing calculator to graph the function. And before I do that, I want to know, I'm going to have to adjust my window. I just know whenever there's a word problem, I'm going to have to adjust my window. So x minimum, x is my input, so I should say p minimum, but it's fine. So when I'm adjusting my window, the minimum I can have is 0. Can't take out less than 0% of the pollutants. Sorry, that's not what I want to do. So you can't take out any more than 0% of the pollutants. My x maximum is I can take out up to 100% of pollutants. So I'm going to make that 100. Okay. Now my y minimum, y is my cost, right? So if I plug in 0, if I take out no pollutants at all, right, I get 0 on the top of the fraction, 0, 0, whatever. So the smallest cost, we should say, is 80,000. And let's say if I take out 100% of the pollutants, that can go up to 800,000. 800. So go ahead and graph this on your calculator and adjust your window, and then just do a quick little sketch of what that graph looks like. Right, and this is P percent, and then this is, there's no way I'm going to be able to write sideways, but this is C. Okay, so go ahead and hit pause, graph this on your graphing calculator, and then let's look at it. Okay, so I'm going to pull up my calculator. Here's my equation. And I'm going to go to my window because I need to adjust my window, right? The minimum number percent is 0, but the maximum percent is 100. And then the minimum cost is $80,000, and the maximum cost is $800,000. There we go. Now, the big thing is this Y scale, and actually even the X scale. So right here, this button tells you, so if you see up here, it says the distance between tick marks on the axis. I do not want like thousands of tick marks on the X axis. So I'm going to change this scale to maybe 1,000. And let's see if that makes it a little bit more manageable to look at. Same thing here. I'm going to change my X scale so that every tick mark is 10. I think it'll make it look a little bit nicer. Then I'm going to hit graph. And even then, like, it's very hard to see, right? These are so strung out. So let's do, this is 10,000. I'm going to put 0 in there and see what that looks like. So much better, right? I can actually see individual tick marks. So I'm just going to do a quick draw of this graph. So it's doing something like this, more or less. And what ends up happening is I can't have more than 100% of pollutants taken out. So there's a vertical asymptote here at 100. Right? I can't cross over 100%. Okay, so it said use a graphing calculator to graph this function. Boom, done, awesome. Then it says you are a member of state legislature that is considering a law that would require utility companies to remove 90% of the pollutants from their smokestack emissions. The current law is at 85%, and they want to increase it to 90. How much additional cost would the utility company incur as a result of the new law? So what is the cost of 90%, right? And and then let's subtract what is the cost of 85%. And that'll tell me the difference, right? That'll tell me how much more I'm going to have to pay. So we can just do this on our calculator. So if I go back to my calculator and I do second trace, so calculate. I want to calculate a value. So right here at number 1, I'm going to hit enter. And I want to know when X is 85%. There's my number right there. 453,333.33. So this is 453,333.33. So that's how much it costs at 85%. That's how much it costs your company. Now let's do that. So second trace. value, so number 1, and I want to know what does it cost to do 90%. And it's $720,000. So if I subtract those, I get a difference of $266,666.67. That is a major dollar increase. Increase, right? Because it's a word problem, so we have to answer in a sentence. To go from 85% to 90%. That's a massive amount of money for a 5% increase. So we're just using our graphing calculator to our advantage and doing all of this work on our graphing calculator. Okay, let's look at our last problem. Here we go. Last problem, if anyone is fair-skinned like me, you will relate to this, okay? It says, for a person with sensitive skin, the amount of time, T, in hours, the person can be exposed to the sun with minimal burning is modeled by this equation, right? T 0.37 S plus 23.8 all over S, where S is between 0 and 120. And this is what we call the sensor scale reading, okay? So the sensor scale is based on how strong the UV rays are, right? So like how intense the sun is. So as the sun becomes more intense, we're able to figure out how long we can be out in the sun, essentially, okay? So it says, find the amounts of a time a person with sensitive skin can be exposed to the sun with minimal burning when the sensor scale is at 10. So I want to find T of 10, right? I want to find T of 25. So, and then I want to find what if the sensor scale is at 100. Now I can plug this in and solve it or whatever, or I can just graph the equation and then use my value feature to find what this is. So let's do that because that sounds way easier, right? So I'm going to graph this. The top of the fraction is 0.37x plus 23.8, and then that's divided by x. Now let's go to our window because we had crazy, right? So x, the input is my sensor scale, which goes from 0 to 120. And I'm going to go ahead and keep the scale at 10, just so I don't have 120 tick marks. Okay. And then the maximum number of hours you can be exposed to the sun is 0 to 10. I don't know, 5. I don't know. And then I'm going to change my Y scale back to 1 because it's just going from 0 to 10. And I'm going to hit graph. So here's the graph of how long people can be in the sun. I want to know if the UV rays are only coming at me at 10 sensor scale, so value of 10, how long am I allowed to be in the sun? And the answer is 2.75 hours. So this is 2.75 hours. I think this means without sunscreen too, right? The next one, what if the UV rays are at 25? So I'm going to go value, 25. Now it's only 1.322 hours. So it's decreasing, right? Because the UV rays, the intensity of the sun is increasing, so the amount of time you can be outside is decreasing. What if the sensor scale is at 100? So let's do second trace. 100, enter. 0.608 hours. And I can figure out what that is in like minutes, but I don't really want to, so I'm not going to. All good? So we're just using our calculator, makes it nice and easy. I can just plug in my values that I want, okay? Part B says, if the model were valid for all sensor readings, as long as they are greater than 0, okay, what would the horizontal asymptote be of this function? What is the minimum number of hours that you can be outside regardless, right, of like if the sun's not even out? What's the minimum that you can be? Sorry. If we're like on the sun, what's the most amount of time that we can be outside? Like no matter what, the minimum. Okay. So basically, it's just asking me for the horizontal asymptote. So I'm going to look at this function, and is it top heavy, bottom heavy, or balanced? And hopefully, we see that the function is balanced. Function is balanced. So since the function is balanced, my horizontal asymptote is, and I'm going to take the numbers right in front of my variables. So 0.37 over 1. So just 0.37 or 0.0 or 0.37 is fine. Okay. So 0.37 hours is the shortest amount of time for minimal burning. So anything above 0.37 hours and you are risking getting burnt. So hopefully that makes sense. So anything above 0.37 hours and you could get burnt depending on the UV rays of the sun. Okay, so that is it for 2.6. Please reach out if you have any questions. I know that was a lot of information thrown at you, and we will practice more in 2.7, so don't stress too much. But if you have questions, make sure that you reach out, ask me in class, send me a remind. We can Zoom, whatever we need to do. And I'll see you when we do 2.7.